Hello everyone, Sharon here again. In this answer video I will explain you the question about the industrial fermenter of the theory lecture. As you can see, I've already drawn a sketch of the situation with the necessary information. The question is, which minimum flow rate is required to maintain the temperature of 30 degrees Celsius in the fermenter? As you have learned in the other weeks, you have to set up a thermal energy balance over the fermenter. It is steady state, so you get the accumulation is 0 is equal to in, so the energy that flows in, minus out, plus a production term. For the inflow and outflow streams, we only have to look at the streams that goes in and outside the cooling coil, because the streams with the black arrow are in the same conditions as the fermenter contains, so that doesn't change the fermenter's energy. So if we know this, and we know that the stream of water that cools the fermenter is VW, then we get P is out minus in is VW times the density of the water times the heat capacity of the water times the temperature of the water that flows out of the cooling coil minus the temperature of the water that flows in the cooling coil, so that's 15 degrees Celsius. In this equation, we know everything except the temperature of the water that flows out the fermenter and the VW, which is the value that we have to calculate. Now the most difficult part follows. How do we determine T out? So the temperature of the water that cools the fermenter and that flows out the fermenter. You have to determine this in a logical manner, which is the highest value T out can be. If the temperature in the fermenter is 30 degrees Celsius, of course this is 30 degrees Celsius. So this is the maximum temperature which will give the minimum flow rate. So T out max is 30 degrees Celsius. If we fill in all this information in the equation and we write the equation in the form of the flow rate, we get VW has to be higher. That's very important because you calculate the minimum has to be higher than the production divided by, that's all what you got here, divided by the density, divided by the heat capacity of water, divided by T out minus T in. Which is, if we write everything in the right dimension, 51 million divided by the density of water divided by the heat capacity of the water in the right dimensions divided by the temperature difference, which is 15 degrees Celsius, and then you will find a value of 0.81 cubic meter per second as the flow rate. Thanks for watching this video and good luck with the final exam.